Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. And in this video, which is a continuation of a gentle introduction to a derivative, we're going to take a look at finding the derivative of a function at an arbitrary point rather than just at a specific point like 1 or 2. We'll look at a function and just say, well, what's the derivative at a random arbitrary point A? To do this again, you just have to recall the definition of the derivative at a point, which was discussed in a previous video, but here you have it. You see it right before you. You have two options, one being kind of the standard slope formula, f of x minus f of a over x minus a, limited as a approaches, or x approaches a. And the other one is more the, what I consider to be the calculus way of doing it, which is as h approaches 0, you're considering f of a plus h minus f of a all over h. Now, I'm probably going to go ahead and use both methods here just to showcase kind of how you can make the right choice. There is no such thing as a right choice, by the way. It's they both work, but I should demonstrate both. So let's go ahead and start with the slope looking version of it. So f prime at a is defined to be the limit as t approaches a. We're not dealing with x's in this problem, of f of t minus f at a all over t minus a. All right, so f evaluated at t. Well, that's just going to be, let me write this in here, 3t minus 1 over 5t plus 3. That's in a numerator, by the way, minus that same function, but instead of plugging in t's, we're plugging in a. So 3a minus 1 over 5a plus 3. And that's all divided by t minus a. So here's the deal. I harp on this with my trig students, my college algebra students, and my pre-calculus students. I give them nonstop problems on simplifying compound rational expressions, or complex fractions if you want to call them that. Because when you reach calculus, you've just got to do it all the time. So here we have it. Let's go ahead and multiply both numerator and denominator by the LCD. Now, I should not have to tell you why, but you should not want to add those two fractions up in the numerator. There are bad instructors out there who teach students to do that. Oh, you add those fractions first and then do all this other hocus pocus. That's a terrible way of doing these problems. You should not do that. Instead, just find the LCD between numerator and denominator and multiply both top and bottom by the LCD. Another thing I should mention here is in the denominator, leave that factored. The only reason why you're multiplying by the LCD is to get rid of those stupid fractions in the numerator. That's what you're going to multiply out. You're going to distribute that stuff out, but in the denominator, don't distribute things out. The denominator is kind of a passenger in this process. The one that you're actively working with is the numerator to kill off those denominators there. So let's see, this will be the limit as t is approaching a. We have now a 3t minus 1 times the 5t plus 3's cancel, so you just have a 5a plus 3 minus quantity 3a minus 1 times the 5a plus 3's cancel, and I'm left with 5t plus 3. All right, and this is all over that t minus a. Again, do not distribute out that denominator. It's just a passenger in this process. And to be honest with you, when I'm teaching, I often don't even rewrite that denominator. I just say over the denominator because I know that I'm going to have a process that I have to go through to clean up the numerator. So I might do that in future examples. But before we continue, I need to give you a fair warning. I've seen it. I've taught this course for 15 years. I totally know what the common mistakes are. I've taught thousands of students. I know what they tend to do, what we as human beings tend to do. We forget parentheses. So if you do this and you don't write parentheses, you're wrong. I mean, it's completely wrong, right? People do this all the time where they just don't write parentheses. It will be marked wrong. It is completely wrong. That is not correct. You need to use parentheses when you do your distribution. So be very, very careful there. Now that I have completely distributed the LCD, I will continue with my algebra. And I didn't bother stating it, but I should state it now. We cannot use direct substitution because if you allow t to equal a, you'll get a minus a, which causes a division by 0. So direct substitution was never an option. All right. Here's the big old fraction bar because we're going to need it. And you start your distribution processes here, right? So 3t times 5a is a 15at. I just write that in alphabetical order. And then we have what? 3t times 3, so it's plus 9t. And then we have a minus 5a, and we have a minus 3. And now just be careful. I kind of do it very quickly because you've had years of algebra, so I assume that you already know how to do algebra. But I'm just letting you know, students often make the mistake of doing bad distributions. 3a times 5t is definitely 15at, but it has a negative in front of it. So watch that negative. Minus 15at. And then 3a times 3, well, that's 9a, but it has a minus in front of it. And negative 1 times 5t is a negative 5t, but we have a negative in front of it, so it's a positive 5t. And finally, negative 3, but with a negative in front of it, so plus 3. Just be very aware. Be very, very careful. And this is all over the denominator. Notice I've already started using that notation because right now all I need to do is just clean up the numerator. Let's see. This is the limit as t approaches a of not so big of a fraction bar, to be honest with you, because the 15at and the negative 15at, they cancel. The 9t and the... Oh, nope. The 9t doesn't cancel with anything. Sorry about that. But the negative 3 and the positive 3, they totally cancel. Let's see. 9t plus 5t is 14t. And negative 5a minus another 9a is a negative 14a. And now I will write in the denominator. It's t minus a times 5t plus 3 times 5a plus 3. I'm pretty okay with students just noting off to the side that this is 14 times t minus a, so they don't have to rewrite the whole silly fraction, because then they could see, oh, the t minus a is cancel. And that's awesome because now I can use direct substitution. It won't cause division by 0. And when you do that, remember, once you do direct substitution, that limit no longer is there. I'm letting t become a. So I have 5a plus 3 times a 5a plus 3. Oh, by the way, you should not leave it that way. Those pictures are the same picture, so that's a 5a plus 3 squared. 14 over a 5a plus 3 being squared. That is the derivative of that function evaluated at a. And of that function, I mean that rational function up there. Now, what this means is if somebody says, I need to know the slope of the tangent line at 10, since I have the derivative at a, I could just let a equal 10. And now I know what the derivative is, or the slope of the tangent line is, at 10. If they gave me pi, I could plug in pi. If they gave me negative 14, I could plug in negative 14. Now, I did say that I would use the other definition just so you could see them side by side and kind of make your judgment as to which one is better for you. So I'll go ahead and use the other definition as well. F prime at A, again, is defined to be the limit as h approaches 0 of f of a plus h minus f of a all over h. And that you cannot use direct substitution with. Did I mark down that I used direct substitution last time? No. It's not a necessity, but I am just going to make a little note here that I use direct substitution to get that moment. Most people do not use that notation, but I do because I find it to be important. So anyhow, limit as h approaches 0. I am going to go ahead and plug in a plus h into my function. So that's 3 times the quantity a plus h minus 1 all over 5 times the quantity a plus h plus 3 minus my function evaluated at a, 3a minus 1 over 5a plus 3. Now when you look at this, and this is all over h, this looks worse than the previous problem. And I would agree, it totally does. But I'll still kind of run through this. I do want to mention again that it is very common I will see people not evaluate a function properly. Probably the biggest mistake I'll see here, and if there's an instructor watching this, they're going to nod their head. They're going to say, oh, yeah, I've seen this so many times, it's annoying. So f of a plus h is definitely not 3a minus 1 over 5a plus 3 plus h. A lot of people do that. They just look at f of a and they add h. That just means you do not know algebra. Go back to start. Don't collect your $200 or whatever it is for Monopoly, right? So you have to relearn functions if that's what you're doing. So just remember, don't make that mistake. All right, I'm going to multiply both numerator and denominator by the LCD. LCD. Notice that my notation gets shorter and shorter as I move forward because this is algebra. So you should know it. That's the limit as h approaches 0 over a denominator. Technically, that denominator is equal to h times the LCD. Okay. And the numerator is just going to be, let's see, let me use a bracket here. Actually, I'll use a parenthesis. The first numerator right here is a 3a plus 3h minus 1, and you're multiplying it by 5a plus 3. Minus 3a minus 1, and you're multiplying that by a 5a plus 5h plus 3. If you don't know how I got that, do it. Just do it by hand. You'll see that that's correct. This is equal to the limit as h tends to 0 of a big old numerator divided by the denominator. The numerator is a distribution process. So here I go. 15a squared plus 9a. Is that right? Yeah. Plus 15ah plus 9h minus 5a and minus 3. The next group, a little bit dangerous here, but it's going to be a negative 15a squared. Let's see, a negative 15ah, a negative 9a, a positive 5a, let's see, negative 5h, positive 5h, and a negative 3, positive 3. And now you get to look through for things that cancel, like this 15a squared cancels that one. This 9a cancels that 9a. 15ah cancels that 15ah. Let's see, this negative 5a cancels that positive 5a, and this negative 3 cancels that positive 3. So this compresses down very quickly. Just be very aware, though, that you still have some stuff there, a 9h and a 5h. So this will be limit as h approaches 0 of 14h. And this is all over that denominator, which is h times the LCD, which was 5a plus 3 and 5a plus 5h plus 3. Notice the h's will cancel, so we are now allowed to use direct substitution because that will not cause division by 0. So allowing h to be 0, where we only have one of them actually right there, you'll get 5a plus 3 times 5a plus 3, or in other words 5a plus 3 squared, which is exactly what we arrived at in the previous example. It's not that it's shorter. I kind of skipped a little bit of the arithmetic and algebra in there, but it's actually a little bit uglier in this case with the f of a plus h minus f of a over h definition. However, again, it's my go-to definition. I like it. It works really well for other examples. So there you have it. So that's a good finding the derivative of a function at an arbitrary point example. And again, just to illustrate that, here's the function. I'm just zooming out to showcase the function here. And all we're doing is allowing h to go to 0 so that we can find the slope of the tangent line, which is called the derivative. And because we did this problem with an arbitrary a, we are now allowed to say, no, a is over here, let's say. It's the red dot way over here, maybe at -5. If I can park it there. There we go. And then you could say, well, what if h goes to 0 here? Although, to be honest with you, it's a pretty good approximation of the tangent line, even at this distance. But anyhow, so this is a visual of the problem that we're working with. I wonder if I could drag this. Yeah, I can. So here's a visual of the problem that we're working with. And you're just allowing this green point to get infinitesimally closer to the red point to give you a tangent line whose slope is called the derivative.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.